Oh, hi, good morning. I hope you all had a good break. So my name is Raju Datla. I am a scientist at the Global Institute for Food Security. So I'll be chairing this seed and meal innovation session. So this session and the program was developed along with Rex. Due to some conflict, he could not be present for the whole session. Anyway, we have 4 speakers in this session, and we'll have a brief Q&A after each one of those presentations. So our next speaker in the session is Bishnu Acharya. So Bishnu is an associate professor, research chair of Saskatchewan Ministry of Agriculture in Bioprocessing Engineering at the University of Saskatchewan. So his presentation is entitled Valorization of Canola Meal to Multiple Bioproducts. Please welcome.
Good morning, and thank you, organizer, for giving me this opportunity to talk about the work that we're doing. This may be very different than what you have been listening for the last few days, and it's more coming from the engineering point of view than from the plant science or the other aspect of canola. In our research, what we're trying to do is, finding ways to add value to a lot of different agriculture products or byproducts that are produced in the province, and see how we can connect that to more industrial application. So today we're going to talk about the work that we're doing in the value chain of canola. So, first of all, why we are doing this. Globally, there is a push for more sustainable, greener materials, greener fuels in order to enhance the sustainability and reduce the carbon footprint in a number of different processes. And it is estimated that by 2030, this bioeconomy that entails, the agriculture product plus the use of bio-based resources, so the feedstock for your chemicals, for materials, for energy, and other industrial application, that is estimated to grow up to $7.7 trillion. So right now it sits somewhere around $4 trillion, and it is expected that it will grow significantly in the next 4 or 5 years. When we look at where we will be seeing those growth, then the non-food application is expected to see around almost 33% growth, 33% growth. So that's the one of the motivation why we are focusing or working in this area is how can we take the resources that are available in Saskatchewan and develop the process and the product so that we can provide those solutions that can be that we will see in coming years. And then if we look at where those growths are, especially on the non-food application, then it's mostly going into materials for packaging, textile, pharmaceuticals, motor vehicles, all different kinds of application, mostly looking for material fibers. Fibers gonna play a big role in this bioeconomy, and most of the source of fibers are the natural fibers that we see are flax, hemp, and other kinds of crops, and also other crops like the straws are also a good source of fibers that can go into some applications. So what we do in our research, so the goal is to develop novel integrated biorefining systems for the valorization of low-value biomass to high-value byproduct. And since this is the first time I'm speaking in this event, so I just want to give an overview of what we do. Mostly, looking at biomass, how much biomass is there, what are the properties of biomass, how can we standardize those biomass, going into the conversion and technologies or develop different processes in order to convert that into bioproducts. and then pass that information and knowledge to the industry so that industry can take that information and turn it into more commercial ventures. We also try to develop the techno-economic and the life cycle impact of all the product and the process that we develop in order to ensure that the process is profitable to the industry, and also it has a low environmental impact. So in canola processing, or in general in canola, so what we see is, you have the plants. So you take the seed, and then the leftover biomass during combining, they are just chopped into a fine powder and left it in the soil, in the field. And then the canola seed goes into a processing. Three main, we can say two main product comes out, which is the food and which is oil that goes into the food, and also potentially into the biofuel industries as well, looking at the renewable diesel. And then the canola meal that mostly now goes into a feed application. And then also there are other kinds of byproducts that are produced in the process, like soap stocks, bleaching clay, which are either mix it with the meal and goes into the feed application, or they are discarded and landfill. So this is a typical, different kinds of different kinds of in our term, we'll call different types of biomass that are produced. We are not looking at the oil because we know it has its value, and the value is already established. But we are looking into what we can do with the straw biomass, what we can do with the feed, the canola meal, and is there any industrial application for these soap stocks and bleaching clay that are produced in the processing. So canola straw, so when we look at the straw, the lignocellulosic composition, so we see that it has cellulose somewhere around 37 to 40%, hemicellulose around 30%, lignin around 20%, and then other extractives. So whenever we talk about this bioeconomy or bio-based material, that economy will be driven by 5 or 6 major components or feedstocks, which will be cellulose, hemicellulose, lignin, protein, starch, maybe some chitosan and other kinds of polysaccharides as well. So those are the key ingredients that gonna drive that bioeconomy. And what we see in Saskatchewan is we have a good availability of the biomass fibers that could potentially be used to support this industry or to support this feedstock. So if you look into canola straw as well, we have around 37% cellulose. So what we have done is we have developed a process to extract the fiber out of that cellulose. So this is more like the pulp. We talk about wood-based pulp that goes into packaging, that goes into all different kinds of industry. But as we are moving away from plastic to more natural and sustainable solutions, then we will be, we'll be looking at more and more of these biomass or natural fibers that could potentially go into those applications. But that doesn't mean that we're gonna go to a forest and keep chopping the trees to meet our demand. We have to look at that alternative sources, and we believe these alternative sources are the agriculture biomass and agriculture straw. And in our group, we have done that not only with canola, we're working with flax, hemp, wheat straw, oat hulls, and all different kinds of crops that are produced in Saskatchewan, and have developed a process to extract that cellulose that could potentially go into those into this packaging application or even other high-end application that we're working right now. The hemicellulose, which is mainly xylose, can be used as a feedstock for making furfuryls, and also furfuryls is one of the building blocks for a lot of different bio-based chemicals. So we can use that to make those building blocks for all these different bio-based chemicals. It can also be used in xylitol and other kinds of ingredients as well. So there's lots of application for this component. And then lignin is also we have done a lot of work. We have used lignin as a binder in canola meal in order to improve the durability of those pellets. Also, we have developed a formulation for using lignin as a slow-release fertilizer, and we have shown that with urea, it can bind to urea, and we can control the release of that urea depending upon how we modify the lignin or what is required from the farmers. So when we consulted what we heard is typically around 40 to 60% of the urea has to be released right away, and then the leftover can be released within 8 to 10 days. So we believe we have a formulation that can work in that sense. And one good aspect of that is lignin. It adds that carbon to the soil as well. So unlike if there's a plastic-coated slow-release fertilizers, when it can leave the microplastic behind in the soil, whereas lignin is a natural polymer and it can be left in the soil and it doesn't do any harm. Rather than it will provide additional carbon to the soil and maintain the carbon. So these are some of the applications where the wheat straw, the straw from canola could be potentially used. Something that we need to look at. So now looking at the meal, this is a project with the team of my PhD student, Nickerson, and then other two PhD students, Yomi and Talal, and also our collaborator in food and bioproduct sciences, Dr. Darren Korber. So we are looking at what can we do with canola meal other than just sending it to the feed application. So we have carried out a microbial extraction, and we have developed a canola meal extract product, so which is so this is our product, and we have carried out analysis on this, and also we contacted a few of our potential clients, and we sent our sample to them for them to try it in their microbial fermentation. We got a very positive review, and so my PhD student and we incorporated this into a can extract innovation. So it's a startup company that started with my PhD student, Nickerson, if you can stand up. Yeah, so he's a PhD student working on developing this as a startup in Saskatchewan. So we're looking at this, developing that can extract, and also the leftover fiber. We have pelletized those leftover fiber, and it could potentially be used as energy pellets if somebody wants to develop this more for the energy application, or it could also be used in making boards and other kinds of materials. So we have pressed them into a board that could go into the construction industry or any other type of material applications as well. So again, what I'm trying to show is, right now we are sending this canola meal at around $450 to $500 per ton out of the country. But within Saskatchewan, we can do a lot of processing here in order to add much more value to those canola meal. So when we look at the extract, and then that extract, we are looking mainly for the fermentation industry or the biotechnology industry. And in the next slide, I'm going to explain why the focus is on the biotechnology industry, and also it could go into adhesives and other kinds of chemical industrial industry as well. The extract that we have, it contains up to 75% protein. It's a microbially extracted, so there is no harmful chemicals used, more eco-friendly, and also it has a lower operating cost. And just to let you know, we are working with the solvent extracted toasted canola meal. And also it contains hydrolyzed protein in the form of peptides, and they are highly soluble in hot or cold water or cold liquid. So we try to mix that with milk and in hot water, and it's completely miscible there. And it also contains all major essential amino acids as well. We went from small lab scale extraction from 150 ml in an incubator to proof of concept to 5 liter, and then carried out a 200 liter extraction as well. And we have seen the process is very scalable, and we will be partnering with the Saskatchewan Food Development Center to see how we can scale it further to a larger scale. So why microbial fermentation? So I think the next presenter, Dr. Nickerson, he's going to talk about why canola protein, or the challenges with canola protein to go into the food market. But what we are thinking is that there is this another evolving market especially on the biotechnology industry, that are looking for this kind of nutrients, for this kind of nutrients. We use microbes for growing vaccines, so microbes for producing antibiotics, for fertilizer, for chemicals, for any other kinds of food. Especially in Saskatchewan, there is a huge interest in going into food fermentation. So a lot of investment has been made in fermentation technology, so that could be used for adding more functionality or value to the food products. And those microbes that are used, they also need the nutrients as we do to grow and then convert the carbon or carbon into some value-added product. So that's what we are trying to provide, that nutrients to those microbes, so that they can take that and then use that nutrients to do their job. The product that we have right now, it can meet the industry requirement as well. So it's sterile, it's highly soluble, and also it can be filtered it can be filtered to the point where it can be used for the industrial submerged fermentation. Again, looking at the value of it, the established market in the biotechnology industry is somewhere around 190 billion. It's gonna get to 360 billion by 2032. And a significant portion of that growth will be seen in North America. So North America is going to see a significant growth in fermentation in the fermentation sector, and definitely they will be looking at more of this alternative. I cannot say for pharmaceutical because they are always looking at the consistency and the high quality media. But if we look into food fermentation, I'm pretty sure that they will always be looking at some very competitive media that can be used to reduce their production cost. And I believe this extract that we have from canola meal can provide that solution. And also on our own side, we have tried to see how this media works on different kinds of microbes. So we're working with bacteria, we're working with fungi, and also through other clients who are working with yeast and other kinds of microbes as well. And what we have seen so far is the yield or the growth of the microbes are not affected, or the growths of the microbes are similar to what we get from the standard media that is from yeast extracts, which is currently used in the market. So we could see that our media works, or our extract works equally like that of yeast extract. So the other application of the protein, so what we have developed is mostly focusing at fermentation, but if we can get some crude protein out of canola meal, then that could also go into this adhesive industry as well as an industrial commodity. So right now, most of the adhesive that is used are coming from phenolformaldehyde, and there is a lot of changes coming up that would limit the use of phenolformaldehyde in a lot of those adhesive applications. So recently we have seen there is a growing interest in finding alternative bio-based adhesive materials. So some of the publications that we see, significant growth in the publications and the research work around developing these bio-based adhesives, and especially growth in protein, mostly looking at soybean protein, but we feel that canola can also play the role, or the canola protein could also be utilized in making those adhesives. So we are also working to develop some adhesive formulations using crude canola protein. And then spin clay and soap stocks. So I'm not sure how much you follow these tire industries, but almost 25% to 30% of the tires contains carbon black. And that carbon black is originated from petroleum oil or the petroleum sources. And the tire industry has the mandate that by 2050, their tire has to be 100% sustainable. That's where a lot of big tire industry like Michelin and other kinds of other tire industries, they're targeting that by 2050, they're trying to be 100% sustainable. So if it is 100% sustainable, that means that 25 to 30% of that carbon black has to be biosourced, or has to come from the source. So what we are trying to do is, we did our preliminary work on the pyrolysis of those soap stocks and the bleaching clay that we get in a normal pyrolysis system, and we found that we can carbonize them to produce some high-quality carbon that could potentially go as a carbon black in those tire applications. However, it has a very high ash content. So we are working on a different process that could potentially separate this carbon black and the ash in the process itself, so that the carbon that is generated can go into those tire industries. And then the ash that is coming out, which is rich in phosphorus, calcium, and sodium, especially coming out from the soap stocks, that could go back into the fertilizer industry. So we could actually produce these two products by separating them in the process. So we are in the process of developing that system that could potentially do this for us, so that instead of discarding or trying to mix that back into the canola meal, it could actually find its application in this high-end sector. So that's the last slide from me. The takeaway message is when we talk about modifying plants, and when we talk about modifying the seeds and the different things that can be done, we can also think about how those affect this other product development, and how does it contribute to that circularity approach. So again, my takeaway message is we should focus on that circular approach, and when we develop any plants, we should also see the food aspect of the plants, but also what are the non-food application of those plants and how that can serve this growing bioeconomy. So I'd like to acknowledge all my teammates, and also NSERC, MITEX, Saskanola, Government of Saskatchewan, ADF Fund, Saskatchewan Food Industry Development Center, NRC for helping us with the characterization, and the University of Saskatchewan. Thank you.
Yeah, thanks, Bishnu, for your great talk. So we'll take some questions.
Thank you for your excellent presentation. If all the canola straw is planning to be used for other end products, doesn't it compete with soil organic matter?
Yeah, so the way I see it is, and the way we grow the canola, I don't think that all of those straw is going to go into this industry. So I think we grow a significant amount of canola. Even taking 10% or 15%, I think would be a good industrial, size application. And then the idea is that the leftover lignin, if you can find a way to put it back into the soil, then it's actually adding, the carbon back into the soil as well. So.
Great work. I'm curious if you're looking into plant-based protein industry, because it's developing. I believe it's got great prospects long-term. And in that industry, the number one protein is soybean, right? Soybean protein concentrates and isolates are dominating. And canola proteins have complementary and often can command higher premium than soybean protein. And they're working with any companies like DSM who are looking into canola protein properties and marketing it.
Yeah, so the product that we're working on right now, this canola meal extract, which is like almost 75% protein in there, we are not right now focusing on the food side application of it. We want to see like what are the options there, or how this canola meal protein can get into the food side. I believe there are lots of hurdles to pass before it can go into the food application. But where we see as a very near opportunity is this fermentation industry, because we are feeding the protein or the extract, the nutrients from canola meal to the microbes. So we feel that it will have a much less regulatory things or regulatory barrier than getting into the food application. But again, we'll hear from Dr. Nickerson more, what are the challenges getting into food application. But that's my understanding right now is getting the canola protein to food applications. There are certain hurdles there. So,
Mark.
Okay, from slide out, there's actually a lot of interest in your fermented meal extract. So I'm going to combine two questions. Does the extract concentrate any anti-nutritional components? And is the process implemented to remove the bitter taste of canola meal?
yeah, that's a very good question, and it's something that we're currently analyzing as well. On what are the what we did so far is we analyzed how much protein is there, what is the amino acid profile of those proteins, and other things. We are further looking into some other anti-nutritional factor in there. But again, the way we see it is like getting this product into fermentation. Some of those anti-nutritional factors may not play that bigger role in the microbial fermentation than developing this product for human consumption. So that's where we're thinking it can easily get into this microbial fermentation than bringing that into the food fermentation.
Okay. Thanks, Bishnu. Please join me. So our final speaker for this session is Professor Michael Nickerson. So he is Saskatchewan Ministry of Agriculture Research Chair and a professor in the area of protein bioproducts, quality, utilization in the Department of Food and Bioproduct Science at the University of Saskatchewan. So Michael will present opportunities and challenges for canola meal in food applications. Please welcome Michael.
Okay, thank you, everyone. Thank you to the organizers for inviting me. I get the privilege of speaking right before lunch, which tees up my talk all about food. So after my talk, you'll definitely be hungry. So I want to talk about some value-added opportunities from canola meal, and this builds on some of the work that Bishnu has done about the value-added uses of the meal. And a lot of our work really pushes on, this provincial growth strategy in which we want to up the crushing capacity in the province, and we're left out with all this extra meal. And although I recognize that this meal is going to be sold, it's going to be transported for dairy cow in China, in the U.S., but as Bishnu talked about it, is what are the other value-added opportunities that we can explore to expand that diversification piece. And I won't go through the whole canola meal production process, but one of the big challenges is we have a huge capacity of the hexane sulfantized meal, right? And this meal has, I'll talk a little bit in a minute, but the proteins tend to be denatured. There's excess hexane. There's challenges that inhibited its use in food applications. And then we have the cold press meal that we typically use for the food applications because we don't have excess hexane, we don't have gums or oxidizing clays in there. And Bishnu talked a little bit about fiber, and there's other compounds in there, bioactives like phytic acid, choline, and sugar and molasses that we can extract from these meals. I want to focus on the protein because that's the best part of the meal. And just the composition down there, but the cold press is really the target of the food industry for now. And some of the big differences between the two meals, that if we look at the hexane extracted meal, there's always residual hexane. And that's challenging because Health Canada has these regulations about only allowing certain limits, which kind of prelude its use in the food applications. Presence of bleaching clays and gums also inhibits its use. And through that heating process, you lose a lot of nutrients. The protein gets denatured, which is it's less functional as an ingredient. And I'll talk about functionality in a minute. Versus the cold pressed meal, which a lot of this heat damage is not obtained. We don't have the hexane, we don't have the clays, so it makes it more applicable to food applications. But one of the questions that we have is could we look at ways that we could change the process to remove some, not all the meal, some of the meal during the typical process, and not add the clays, not add the gums, and look at could we use that as a food application. So looking at different ways we process the meal. But when we talk about canola proteins, there's two main ones, gasiferin and napin. And this really comes down to the genetics. Different varieties have different makeups and ratios, and these have different functionality. And when we talk about functionality for food, I'm talking about, is it soluble? So I want it in a beverage. I want it suspended, not falling down to the bottom. I want it to have good emulsifying properties. So an emulsion is like a salad dressing. You're mixing oil and water. The protein keeps it stable so it doesn't float on top. Water and oil holding, this is important for meat analog applications, and gelation for gel products, and I'll talk a little bit about that in a minute. So depending on the source of the canola, the ratio, how we extract it, we can get different performance of our food ingredients. And there are a number of different processes to make our ingredients, but they come out as either, ideally we wanted a beige or beige bland color product. So it can go in a whole range of applications. So that's sort of our intended goal. There are a number of processes that we can use, and I won't go into details, but some of these are used commercially, others in the lab, but a lot of people are working on how can we extract gasiferin-rich fraction or a napin-rich fraction, or maybe we want to blend them to get different properties, and we can control how much protein we extract and which ones we can extract depending on what process we use. But one of the big challenges is, like many plant proteins, they don't taste the greatest, right? The color and flavor are the biggest challenges for canola. Functionally, they're actually quite good. They perform really well in different products, but it's always the color and flavor. So we can improve fractionation, improve color and flavor. I'll talk a little bit about that in a minute. Functionality. Labeling is another challenge, right? So Health Canada came out and it's associated with an allergen label that you have to put on food products containing the canola protein. And supply. So we have lots of canola, but we need more manufacturers producing the isolates for the food industry. And you can use these in a whole range of applications, from sports drinks, nutritional beverages, non-dairy milks, and baking. So one of the projects that we were working on is to address this flavor issue, right? And so we were working on a project with NRC of how can we use absorbent resins and integrate it into the wet extraction process when we create these isolates to pull out these volatile compounds, or we're pulling out some non-volatile to reduce that flavor compounds that consumers don't like. And we were actually we didn't eliminate everything, but we did a pretty good job pulling off these compounds. And it was actually quite a pleasant tasting canola protein in the end. And when we do that, everything we do in processing, it has an effect on functionality or nutrition. So in this process, we were pulling out these compounds, and we saw it actually improve solubility. So these proteins, once we pull out these compounds, they behave better in a beverage, so we don't have them sedimenting out. And same with emulsifying. They're better for an emulsion-based product, which I'll talk about in a minute. So one of the big functional properties that we want to target in canola is how does it form a gel? And this is just an example of a study that we did a while back looking at how we can control the self-assembly of these proteins to get different structures, right? So just by changing the composition, we can add different other ingredients like carbohydrates to get different textures of our gel products. So why is this important? Because everyone loves a good vegan egg, right? And so the plant-based food market is a really big market. And there's a lot of challenges to create these products that mimic, say, a real egg, right? So this project really looked at using a canola-based, protein-based vegan egg formulation and really focus on, one, making these gel-like structures using these emulsion systems. So we protein stabilize these so there's little nano drops of oil in that creamy layer, and then we throw it on a skillet, and we design it so that they actually form a nice solid gel at 85 degrees temperature when you're frying your egg, right? So we want to mimic that egg texture, and not only that, but when it gels, we have to control the aggregation to prevent water leaking, because you don't want runny eggs with water coming out of it, right? So then we flavored it and helped with the color, and we created these scrambled egg type products. So this is one opportunity for a gel-based product that's on, not ours isn't on the market, but there's similar ones on the market. Another big issue, because we had our eggs, but now we need our coffee, right? And if you ever have a plant-based coffee, sometimes you have this curdling effect, and this is a big problem. You know, coffee has different acidity depending on when you get your coffee. You have different hardness of water depending on where you live, and that can all impact how much curdles are formed in your coffee. So when we make this plant-based creamer to go in this coffee, depending on all those conditions, coffee and hardness, you can get curdling, right? So we worked with Nestle on a project to how can we circumvent that in their products. Right, so we took the canola protein, we stabilized these nano emulsions, and we actually grafted polysaccharides on the outside of these proteins to actually stabilize it. So it's hard to see in those pictures, but these creamers come in about pH 8, and they're quite stable and soluble, but when you throw it in coffee at pH 4, 4.5, it actually keeps that stability there. So the grafting of those polysaccharides with canola kept these products stable, and then you can enjoy your good cup of coffee with your vegan canola protein milk. But this is a huge market. Everyone drinks coffee. The plant-based coffee creamer market is quite big. So we have our coffee, we have our eggs, now we need some bread, right? And so one of the things, this is all about my breakfast, by the way. So we worked with this project with Dr. Gosh in our department on oleo gels. So these are basically, we talked a little bit about emulsion. So you have little oil droplets. So in this case, we pack these oil droplets so tight and we stabilize it by protein, it starts behaving like a solid. And we can create a texture that holds fat. So we have the solid thing right here on the left or right that can actually hold the oil and hold the fat in a solid-like structure. And the idea is that we want to start replacing saturated and trans fats into our piece of bread. So we did that. So we put it in, and we were able to have the same loaf volume, right? So basically, this is called the crumb, and there's little air bubbles that form during the fermentation process, and the protein and fat help coat the air bubbles to make it stable so your bread doesn't collapse. So this is another example of how we can use canola protein to make new food structures that are healthier. I'm not going to talk about vegan bacon because that's not right. I won't go there. So we talked about food, and Bishnu talked about some of the non-food applications, and this is where the hexane extracted meal that we could pull out these proteins. I'm targeting food, but we can use the same principles to look at non-food applications, whether it's adhesives, the culture media, biofoams, aquaculture feed, whole bunch of different things that we could do for non-food applications. The same principles apply. We just pull the protein out, and it doesn't have to be food grade in this particular case. So here's just one example. We made edible packaging. This is one we did a little bit ago, and made films that basically similar properties as ones made from soya. So this is more sustainable than the petroleum-based. And it has good functional properties, and now we're looking at how can we scale it up using extrusion-based technology. So hopefully we'll be collaborating with Bishnu to see how we can do that. And then here's another project that we did with Dr. Rennie, who's somewhere here, on bioadhesives, right? So Bishnu mentioned that as well in his study. So a lot of opportunity in this non-food space as well, but you notice it all focuses on the protein, which is good. So my take-home message is, I don't want to keep you for dinner. We have a huge potential for canola proteins in the food sector, and there's a lot of value-added opportunities, especially if we can deal with the hexane, removing the clays and gums aren't added, and addressing some of these flavor issues that consumers don't like. A lot of opportunity beyond the feed. So I'm happy to take any questions.
Yeah, thanks, Michael, for an excellent talk. So, any questions from the room?
Well, we certainly have questions from online. Thanks, Mike. I can start off by combining a couple. There's a lot of interest in how you assess the palatability and flavor of your meal extracts and protein products.
So we do two things, or no, we do a couple things. We collaborate with NRC to use their electronic nose, because they don't trust my nose. We also use GCMS to look at the flavor compounds. We use NMR to look at the non-volatile compounds. And ultimately, we stick it on our tongue and say, oh, this tastes good. We put it into products. One way that you could taste, if you're just evaluating protein, if you put it, say, in like a 5% protein solution, you can really tell flavor differences between ingredients just by mixing it and looking at it.
You have some more?
There are more. The top one, people will vote for them. How would you convince crushers in setting up new units for crushing with these modified canola crops? I'm not quite sure what the purpose of that question is. Maybe I'll just skip to a different one. What chemicals are added to these plant-based products? What additives are you adding, and would you consider these healthy?
We're not really adding additives per se. Like everything's food grade. So when we make, say, like a plant-based milk, we're using the isolate. We're adding gums. We're adding lipid. The proteins actually help stabilize the product, control the texture. If anything, you would add a flavor like vanilla or chocolate or other things. So chemicals, we don't add into food. Even preservatives, we don't. You can, depending on your design and your product, you can have it refrigerated, you have it frozen. If you start adding shelf-stable stuff, you probably have to add an antimicrobial agent or preservative in that case. But depends on your product.
Okay, thanks.
Mark, do you have any more?
Any more from the floor? Because there are.
Maybe one last question.
The top question, are canola crushers... Oh, no, hang on, we did that one. A lot of interest in whether crushers would set up a different process to give you better protein. But I think... Do you have any comment about that?
I think it's a challenge, right? Because you have to... they might have to do more infrastructure changes, right? You have to show the cost-benefit analysis to show, hey, there's an economic benefit to doing so. But it is a challenge, but not looking towards market diversification, I think, is wrong. I think you need to keep your options open. And there's room for small growth or small companies to form around this space. But I think that market diversification piece is important, right? And that gives us safety net when markets fail, right?
Thanks.
Yeah, thanks, Michael.
Yeah.
So please join me.
So with this, it concludes this session. We have 4 excellent speakers. They covered areas from engineering glucosinolates by Barbara, and Tegan presenting the power of synchrotron to probe into the seed and seed compositional and components, and Vishnu presenting the diverse applications of canola seed meal, and Michael presenting the protein quality and functionalities. I think we got a full package, and please join me thanking our 4 excellent speakers of this session. I think we may be a little bit running late. We'll be back by 1 o'clock. Yeah, we'll see you back at 1 o'clock for the next session.